All right. I think I'm live now. Can someone confirm if I'm live or not? And if the audio is perfectly clear? I don't see any viewers. That's probably because it's an unusual timing for the contest and same for the stream. Okay. Anyways, am I live now? Can someone confirm? Manak says hands up if you couldn't solve C. Raj, what a performance. Thank you, Raj. Okay. Raj says I just want some instance like how to develop indentation. Priyanshu says, bro, he solve nahi kar paye yaar. I honestly have tried 3 ways of solving it. It just fails to pass pretest 2. Okay. Uh, let's see what that pretest is. Actually, there are many ways of solving B. Okay. My way is also not the best way. But yeah, I did think of a better way now. Okay, Priyank, very tough one. Rashid says yes. Okay, perfect. I am live now. I don't see many viewers today. Only 14 viewers right now. Do like the stream, guys. I only see 5 likes. Anyways, let's start with the stream. We will be solving Codeforces around 802 today, and we will do problem A, B, C, and D. Okay, and I'll obviously go in order only. So let's start with problem A. All right, optimal path. So you're given a table A of size n into m. We'll consider the table numbered from top to bottom from 1 to n, and the columns numbered from left to right from 1 to m. We'll donate the cell that is in the ith row and the jth column as ij. So these are pretty standard things. Okay, now in the cell ij, there is written a number I minus 1 times m plus j. Okay, so basically aij is actually what? I minus 1 times m plus j. This is what our aij is. Okay, now a turtle initially starts in the cell 1 1 and it wants to come to the cell nm. From the cell 1j, it can be one step go to one of the cells I plus 1j, that means go down, or I comma j plus 1, that is go right. So basically, you can either go in the right direction or in the down direction. Okay. Now, a path is a sequence of cells in which for every two adjacent in the sequence cells, the following satisfy. The turtle can reach from first cell to the second cell in one step. The cost of a path is the sum of numbers that are written in the cells of the path. Okay, so we need to find a path. Okay, and we need to find the sum of the path. Okay. Now, for example, with n equals to 2 and m equals to 3, the table will look as shown above. Okay, the tool can take the following path. Okay, so we need to go from 1 1 and reach nm, find the minimum sum of the path. Okay, your writing is not visible. That's yeah, you are actually right. Why is that happening? It's a little weird. Give me a minute. Yeah, it's not visible. Okay, now it's visible, right? Okay, cool. I hope it's visible now. So aij is I minus 1 times m plus j, and we can only go in the right direction or in the downwards direction. And we need to start from 1 1 and reach till n comma m. Okay, cool. And we need to find the minimum possible sum. Okay, so let's do this. Let's look at the very first example only. Okay, so the first example is, I think this is the first example only. So we have 1, 2, 3, 4, 5, 6. Okay. All right. So how I did was I just found out the this path. Okay, and I for some reason knew that this will give me the minimum sum only. Now let's prove that if this will actually give us the minimum sum, or I have an indication that every path will actually give you the same sum. Okay, because if you see, this path is 1 plus 2 plus 3 plus 6. If we had taken 1, then 2, then 4, then 5, then 6, it would be 1 plus 2 plus, no, it's not same actually, 5 plus 6. So this is a larger path. Okay, similarly, if you go like this, then it is 1 plus 4 plus 5 plus 6. Again, the sum of these two are greater than the sum of this one. So this is the answer. Essentially, the minimum sum is actually going to be if you are given this grid, first go like this in the topmost row and then go down. Now, if you see, these values are actually 1, 2, 3, 4 till m. And these values are m, 2m, 3m till nm. Okay. If you compute this formula, find out these values, this is what you're going to get. Okay. Now, if you see the sum of these values, okay, let's skip this m. Sum of all the values from 1 till m minus 1, we have m minus 1 here. Sum of all the values from 1 till m minus 1 is actually m into m minus 1 by 2. Now you need to add all these values. Sum of this is actually n times sum of first n natural numbers, m times sum of first n natural numbers, because it is 1m, 2m, 3m, so on till nm. So this is actually going to be n times n plus 1 by 2. So if you find the value of this, that will be the minimum possible sum for the turtle to go. Okay. So that is pretty much it about this problem. I'll quickly show my code. Again, nothing too much to explain in this one. Okay, I'll show my code quickly. This is the code. Okay. So, okay, so that is exactly what I'm doing. First, I'm finding m into m minus 1 by 2. Then I'm adding m times n into n plus 1 by 2. Okay, and then I'm just printing the answer, and that's it. All right, I hope problem A is clear to everyone, and I think almost everyone was able to do problem A today. Okay, cool. Let's move to problem B now. Palindromic numbers. All right. Okay. Now, for problem B, there are many solutions. Okay, my solution is a bit trickier. What I'll do is I'll try to explain us easier. First, I'll explain my solution, and then I'll explain another easier solution. Okay, cool. Okay. During a daily walk, Alina noticed a long number written on the ground. Now, Alina wants to find some positive number of same length without leading zeros. Okay, thus that the sum of these two numbers is a palindrome. Recall that the number is a palindrome. Okay, this is the general definition of a palindrome. Now, Alina understands that a valid number always exists. Help her find one. Okay, so basically, we are given a large number. We need to find another number with the same number of digits. Okay, such that if you add these two values, the final answer that you're going to get should be a palindrome. And a palindrome is nothing which is read same from the left to right and right to left. Okay, now let's look at an example. Okay, let's take an example. Let's take the last example. We have 3, 8 and 5. Okay, now the easiest way to think of this problem would be to make the final answer as 999. In order to do that, okay, what you need to do is you need to add 4 here, you need to add 1 here and 6 here. Therefore, if you add 6142 385, you will get 999, which is a palindrome. So the answer for this becomes 614. Similarly, for the above case, you had what? 1023. We had 1023. Now, if you want to make this 4 times 9, you need to add 6 here, 7 here, 9 here, and 8 here. So this is the answer for this one. Pretty simple. There is one edge case. If you try to do the same thing for the first example, which is 99. Okay, now since it is 99 and your aim is also 99, you'll need to add 00, which is not possible. You need to add some number which has equal number of digits with no leading zeros. Okay, but this has 2 leading zeros, so you cannot take this number. Now what to do? If you add any number here with this 9, the number of digits will increase. Since the number of digits will increase, we need to come up with a different number. Okay, which we can make after adding something. Now, what should this target number be? Now, there are multiple solutions for this. Okay, the way I did was, basically, this case is that if you have the very first value is 9 and then you have some numbers, right? Okay, so if you had to add this with some another number with the same number of digits, the final answer can be anything. What I tried was, I tried to make it 18881. Since it had to be a 5-digit number. Okay, but since we will add something here to this 9 and the number of digits will increase, therefore I need to make a 6-digit number, which is a palindrome. So what I did was I appended 1 and 1 in the starting and the ending. Okay, and then I made all the other values as 8. Okay, now this is pretty simple. You just need to think of an implementation through which you can do this. But there is a better solution. A better solution would be if you try to make this 1 1 1 1. This is the easiest way to implement. How? Let's see. So, for example, if you had 99 and you wanted to make it 111, because there are 2 digits here, you will have 3 digits here. In order to make 111, you need to add 2 here. Now 9 plus 2 becomes 11, 1 comes here. Okay, again 9 and 1 are 10, so you need to add 1 more here, thus that this becomes 111. Therefore the answer for 99 becomes 12. Okay, so that's all you have to do for problem B. I can show you my implementation, but in that I'm actually trying to make this 181, and that is how I solved it. This is pretty easy to implement, so you can like think of an implementation for 111 as well. Okay, cool. Okay, let me read the chat. Problem B was just check for 9 n times or 1 n plus 1 times. I don't know what you're trying to say, but maybe that is right. For B, either make all 9s or 1 1 1s. Yes, exactly, Aditya. I did the second one also. When would I be able to think like this? It's okay, like you need some practice, that's all. Can you tell for 90909? Okay, I can do that. How to solve for 90909? If you have 90909. Now, since you know the very first digit is the 9, that means the final answer will have 6 ones. Okay. Now, how to make this one? You need to add 2 here. Okay, 9 plus 2 is 11, so 1 is carried. Since 1 is carried here, you don't need to add anything. Okay, this becomes 0 only, and this is 1. Okay, now again you need to add 2. So 9 plus 2 is 11, 1 gets carried. You don't have to add anything here. Okay, and now again you need to add 2, so it becomes 11. So 20202 is the answer. Okay. I did the same thing, but it did not work properly. Maybe there is some issue with your implementation. B, I did the exact same thing, but I didn't accept it. Again, like there must be some issue with their implementation. I made 9 and 9s and 1 1s and printed the answer which has the digits equal to the given constraint. I made 999 9 and 9. The answer which has the digits equal to the given. Yeah, then it should work. How to do for 98? For 98. Okay, let's do for 98. Okay, that is the last one I'm going to take. Okay, and then I'll show you my code. Okay, so for 98 again, since this is 9, we'll try for 111. Okay, in order to make 111, this one you need to add 3 here. 8 plus 3 is 11, 1 gets carried. Okay, 9 plus 1 is 10. You need to add 1 more here, and that is. So for 98, the answer is 30. Okay, yeah, for 98, it's 13. Hi, I did it for 19. 111 minus 98 equals to 13. Yes, 13 is the right answer, but you cannot really do the subtraction here, because if you see, n is actually equals to 10 to the power 5. If n is equals to 10 to the power 5, that means there are 10 to the power 5 digits, and that is something you cannot like scan in an integer. So you need to scan the complete number in a string, and then you need to process it. All right, let me show my code. It's a little trickier implementation because I'm trying to make like 1, then some 8s, and then 1. Can we use BigInt? Yeah, you can use BigInt, but I think like using BigInt for a problem B is like too much effort. Okay, so this is how I did it. If the first digit is 9, then I'm trying to make 1881. Okay, if it is not 9, I'm trying to make all 9s. Okay, that's it. So yeah, I don't think there is a need to explain this implementation because it is a little tough one. Okay, you can actually think of something for 111 that is easier to make. All right, I hope this is clear to everyone. Is there anyone who still has any doubts in problem B? I can take that, otherwise I can move on to problem C. All right, is it clear to everyone? Solved 3 today, really nice, Raman. Okay, Nana says I think your code will fail at 9. I also got failed at test 4 initially. Maybe. Let's go see. Yeah, let's do C. Helping the nature. Okay, little lion. No, it's not lion, it's Leon. Little Leon lives in a forest. He has recently noticed that some trees near his favorite path are withering, while the other ones are overhydrated. So he decided to learn how to control the level of soil moisture or save the trees. There are n trees going near the path. The current level of moisture of each tree is denoted by array. Okay, so we have an array from A1, A2 till A of n. Cool. Now choose a position I and decrease the level of moisture of trees 1 2 till I by 1. Okay, so if this is the complete array and if this is my ith index, you can select all these values and decrease their moisture by 1. Or the second operation is you can select any I and decrease all the trees moisture of all the trees after this index including this index by -1. Or the third operation is that increase the level of moisture of all trees. So if this is the complete tree, you can increase the moisture of all the trees by +1. Okay. Now, Leon wants to know the minimum number of actions he needs to perform to make the moisture of each tree equals to 0. Okay, that is what we need to do. Okay, let's take an example. Let's take which one? Let's take the first example only. I'll first show some examples to give you a better understanding of the problem. Okay, so if it's -2, -2, and -2, since we know all these numbers are same, what we can do is we can actually apply the third type of operation twice. So we need to make two operations such that in every operation we increase all the values by +1. So this becomes 0, 0, and 0. Therefore, in two operations, you can actually make all the values 0. So the answer is 2. Okay. All right. Let's come to the next one. In the next example, we have what? 10, 4, and 7. So we have 10, 4, and 7. The way to do this would be we can actually decrease the moisture of this 7. So we can make this 4. So this becomes 4 and this is 10. We did 3 operations and in the okay, let's write minus. We did 3 operations and subtracted 3 from this 7. Okay, then we take this one and again do -6 here. Okay, so this becomes again 4, 4, and 4. Okay, now since all the values are same, we can actually subtract -4 from all the values and then it becomes 0, 0, 0. So this is -3 operations for this, 6 operations for this, 4 operations for this. So that gives us 13 and 13 is the answer. Now let's take the fourth example. Okay, the reason I'm doing writing all these examples is because I myself wrote all the examples, try to see like if there is a pattern or a way you can like if I'm getting an intuition of how to do this, and then like I can like think of an implementation. So I'll actually take the last example and explain like how you can implement this. Okay, so you have 1, you have -2, you have 3, you have -4 and 5. Now one thing that you need to notice is that since you have a -4 here, okay, and a 5 here, the minimum value in this is -4 and the maximum value in this is 5. This tells us that you need to make all the values equal to -9 first. The reason is because the difference of these two values is 9. So in order to make all these values equal, every value should first become equal to -9 and then you can do like +9 operations of third type to make everything equals to 0. Now how to make -9? That is the trickier part. Okay, the way to do this would be, let's say this is one of the ways. There are many other ways as well. Okay, so you have 1, do nothing, then you have -2. Okay, since you have -2 which is lesser than 1, do nothing, then you get a 3. Since this is 3 which is greater than -2, you will say that I will do 5 operations on this 3, I will do 5 operations on this 3, 5 operations on this 3, so that it becomes equal to -2. So I'll make -2, this as -2, and the number of operations till now are 5. Since I'm doing 5 operations on this one, I need to make all the other 5 operations for these two values as well. Okay, after doing that, this will become -4 will become what? -9 and 5 will become 0 because we need to do 5 operations on these two values as well. Now if you come to -9, you will see that -9 is already lesser than -2, so do nothing. Then again come to this 9. You see that this 0 is actually greater than -9. So do 9 more operations. Okay, so do 9 more operations. Okay, and this becomes, the array now becomes plus 9 operations and do 9 operations on only this 0. So this becomes minus 9. So right now you have done 14 operations and you have made the complete string as decreasing. Now what you need to do is look at this array and see this is minus 9, this is minus 9. So come on to this value. In order to make this minus 9 equal to the minus 2 equal to this minus 9, you need to do 7 more operations such that this minus 2 becomes minus 9. 7 more operations in this direction. So you have this minus 2 becomes minus 9, this minus 2 also becomes minus 9, and this one becomes minus 6. Now you see this is also again equal to this minus 9 only. So you come out to this one and say you need to do 3 more operations on this minus 9 of first type, thus that this becomes minus 9. And now if you see all the values are equal to minus. Now all you have to do is do 9 more operations of the third type such that every value becomes equal to 0. Okay, so and if you see the sum of this is actually 33, which is the answer. Okay, that is how you have to do problem C. I'll do the same logic for what test case, third test case as well. How do we prove this algo is right for C? Okay, how do I prove that? I didn't really think of a proof. I just had this intention, this works, so I didn't really think of a proof. But if you see, I am not making any operation twice. Okay, if I'm actually subtracting some value from any index, then I'm not subtracting in that direction again. That means I'm not duplicating any efforts. That means whatever answer I get from this will be the slow, like the minimum answer. Why can't we make minimum element 0 and then move? How will you make minimum element equals to 0? Okay, you will add like do the third operation for all the elements such that the minimum operation becomes 0. Yeah, I think that is again a good way. No, that won't work. How is it the minimum? I explained that like how you're going to get the minimum. Okay, I'll do the same thing for test case 3. Maybe you'll get a better understanding from that. Okay, so let's take the third test case. Third test case is 4 minus 4, 4. Again, first we'll go in this direction. Okay, we have 4, do nothing. We have minus 4. Since this minus 4 is lesser than 4, do nothing. The next value is 4. Okay, so what you need to do is you need to make 8 operations on this 4 in this direction, 8 operations in this direction, thus that this 4 becomes minus 4. Now, since you have to do 8 operations, this 4 will become minus 2. Okay, and if you see this minus 12 is also lesser than minus 4, so it is decreasing. We have done 8 operations still. Okay, now you need to move in this direction. Since this minus 4 is greater than minus 12, you need to make 8 operations in this direction, thus that this minus 4 becomes minus 12. So this minus 4 becomes minus 12. Again, 8 operations for this as well, so minus 12, and 8 operations for this as well, so minus 4. We have done 8 more operations. Now this is also minus 12, so do nothing. This is minus 4. So again do how many? 8 operations. 8 operations. Thus that this minus 4 becomes minus 12. Now since all the values are equal to minus 12, do 12 more operations so that everything becomes equal to 0. And if you see the sum of this is 36. The answer. Okay, so that is how you had to do this. Okay, I will show you my implementation as well. Is the logic clear to everyone? Is the logic clear to everyone? Great effort. Thanks, Harshit. Prajul says awesome content. You're welcome. What will be the overall complexity? It is open. First, we are actually moving from left to right, so that is open, and then we're moving from right to left, so that is again open. So the overall complexity is open only. Is this clear to everyone? I'll show my code. I used to say n square. No, it's not n square. You see, n is actually like 10 to the power 5, so you cannot go for n square. Let me show you my code as well. All right, so the code. Okay, cool. Okay, so first I'm scanning the complete array. Okay, then I'm going from left to right. Okay, this is left to right. Okay, I'm going to left to right. I'm tracking all my operations. Okay, then I go from right to left and do the exact same thing. There's no difference between these two for loops. Okay, I do the exact same thing. Okay, and then in the end, whatever my value is, my first value is, because I know all the values in this array are equal now. Okay, whatever that value is, I just add the absolute value of that into my answer and I get the answer. Unable to, Meher says unable to solve problem C in context. Can you please guide a little bit? Yeah, like I remember when I was stuck at problem C, what I did was I did A2OJ ladders. A2OJ ladder problem. I don't know if it's still available, but I did that. Yeah, A2OJ, like the support for A2OJ stopped. So problem C ladder is this one. You can actually do this ladder. Okay, and in this ladder you will have all the like good problem C's. If you do all these problems, then you'll definitely be able to do like problem C's in contest. This is what I did, and after that I could see that I'm now able to do problem C. I've done a ladder of problem C and D, I think. Okay, cool. Should I move forward to problem D? I don't know, for some reason this link is not opening. Okay, let's see. Anyways, let's move to problem D. River locks. Okay, I'll get a plus 50 after this. Plus 80, sorry. And my rating right now is 1819. So I'll be at 1899. Really nice. I wish I hadn't done a wrong answer on problem D. I first actually got a wrong answer on pretest 3. The reason was because my like I missed a less than equal to sign in binary. That's why I hate binary search. When you used to get stuck on problem B or C, then from where you used to refer the solution. I used to look at the editorial and I used to look at other people's solution. That is how I used to like do the solution. First I used to solve it. Then okay, cool. Anyways, never mind. Let's move to problem D now. Is problem A, B, and C clear to everyone? Is there anyone who still has a issue with any of these problems? If yes, they can let me know. I can explain them again, like some part of it again. Otherwise, we can move forward to problem D. Problem B. Rahul says problem B. What is your doubt in problem B, Rahul? All right. Got TLE in problem B. You must be doing something. Like, is there something specific you want to ask me to verify one? Okay. Let's move to problem D now. Recently in Devanovo, okay. Recently in Devanovo, a huge river lock system was built. There are now n locks. The ith of them has a volume of VI liters, so that it can contain any amount of water between 0 to VI. Each lock has a pipe attached to it. When the pipe is open, 1 liter of water enters the lock every second. The lock system is built in a way to immediately transfer all water exceeding the volume of the lock I to the lock I plus 1. If the lock I plus 1 is also full, water will be transferred further. Water exceeding the volume of the last lock pours out of the river. Okay, so basically, let's take this example only. What we have is, let me make this lock. So we have, okay, let me read the problem first. To make all locks work, you need to completely fill each one of them. The mayor of Divinovo is interested in two independent queries. For each query, suppose that initially all locks are empty and all pipes are closed. Okay, so this complete lock is empty. Okay, and all the pipes are closed, and we know that uh, this pipe in a okay, when the pipe is open, 1 liter of water enters the lock every second. Okay, then for each problem, suppose the initial all locks are empty and the pipes are closed, then some pipes are open simultaneously. For the jth query, the mayor asks you to calculate the minimum number of pipes to open so that all locks are filled no later than tj seconds. Okay, all right. So let's take the very first example. We have 41541. So we have the first lock is of length 4. Okay, so I'll make a lock of length 4. Okay, so we have 1, we have 2, we have 3. This is liters. Okay, this is just the marking that I'm making to make it easier to understand. Then we have another lock of length 1 of size 1 liter. Then we have another one of size 5 liters. So this is 5 liters. Okay, then we have another one for 4 liters. So we have 4 liters lock here, and then again 1. So this is 4 1 5 4 1. Okay, and we know that every lock actually has a pipe above it. Okay, and all these pipes are closed at the moment, and this one pipe can actually give me 1 liter per second of water. Okay, Dhiranjay says, can you check Jingli's solution? Problem C is very short. Okay, let's take that very fast. Yeah, this is something nice. First, he's left to right, B 5 plus the difference. If B is less than 0, A 0. Okay, at that exact same thing I'm doing. Then answer plus equals to that's okay. This is also a nice solution. Okay, we'll look at this like how this is working. All right. So this is the test case. Okay, now let's first forget the queries. Okay, and first see like let's take what 5. What if we are given 5 seconds? If we are given 5 seconds, is there any way to fill all these locks? If we are given 5 seconds, it is obvious that we need to open the very first lock. If we open the very first lock, okay, very first pipe, we know that in 5 seconds we'll get 5 liters of water. Since we have 5 liters of water, we will fill this, and this. Plus, we'll have one additional liter which will get poured down to this. Okay. Now, since this is already filled, we do not need to open this. So let's move forward. Let's come on to this pipe. Again, open this pipe and fill this. So since 5 liters for 5 seconds, this will get completely filled, but it won't be able to send water forward. Okay. Okay. Now again coming on to this one, let's open. Okay, so we opened this one, and now let's open this one as well because we need to fill values for this one. Since we have 5 liters, we'll fill this, and this. Okay. So by opening 3 pipes, we were able to fill all the locks in 5 seconds. Okay. So and we need to like tell the minimum number of pipes that we need to open. Okay. So this is one pipe, this is one pipe, this is one pipe. So the answer for this 5 seconds is 3. Now let's try to do this the same thing for 6. Okay, let's try to do the same thing for 6. I'm actually like telling you in the exact same way how I approach the problem. Okay, so that you can also understand like how to solve these kind of problems. Okay, so I'll actually make more pipes. Okay. And I'll mark that this is for this was for 5 seconds. Now we are trying for 6 seconds. Okay, since we are starting from the very first only, we first have 6 seconds. Now we have 6 seconds. Now we have 6 seconds. Okay, so in the very like first pipe will give me 6 liters of water. So we have 1 2 3 4 1 2 liters of water are left, so that will be carry forwarded to this one and this one. Okay, now again we don't need to open this pipe. Okay, because this is already filled. Now let's open this one. Let's open. So we have opened this pipe. Now let's open this one. And we get 6 liters of water again. So we have 1, 2, 3, 4, 2 liters are left. So they will come here. Now again, since this is not filled, open this pipe as well. Again, we will get 6 liters of water, 1, 2, 3, and the remaining 3 liter will flow into the river. Okay, this is the river. Okay, so basically by again opening three pipes, we were able to get a solution for 6. Okay, let's do the same thing. Let's do the same thing for 4, or let's do the same thing for 3 first. If you see, if you try to do the same thing for 3, if you try to do the same thing for 3, you will see that in the very first pipe you'll get 3 liters of water, 1, 2, 3. This lock is not filled yet, but there is no other way to fill this lock. That's why for 3 you will get an answer of -1, that it is not possible. Can we do this for 4? If we have 4 seconds, can we do this? Let's see. So we have 5 pipes. Okay, these are the 5 pipes. Okay, how extra 1 liter overflows from second to third? Actually, that is given in the question, that if you have extra water, the volume of the lock I to the lock I plus 1, like the lock system is built in a way to immediately transfer all water exceeding the volume of the lock I to the lock I plus 1. So there is some mysterious way through which all the water from the ith lock can be transferred to the I plus 1th lock. All the extra water can be transferred. Okay, so like from the second lock you can actually transfer water to the third lock, even though the third lock has a higher height. Okay, so let's try to do this for 4. If we have 4 seconds, we will get 4 liters of water from the very first tap. So we have 1, 2, 3, 4. Now since the second tap is not filled, we need to open the second tap. So 1, 2, 3, and 4. Now since this is not filled, we open the third one. Okay, so we get 1, 2, 3, 4. Now since again this is not filled, we open this one. Okay, and we get 1, 2, 3, and remaining 1 liter flows. So by opening 4 taps, we were able to get an answer for 4 seconds. Okay, now the idea is very clear. I hope by after this, we need to first apply binary search and find out by using how many minimum number of like what is the minimum number of seconds you require through which you can at least get one answer. Okay, in this case that is 4 seconds. That with 4 seconds, if your time is greater than equal to 4 seconds, then you will have an answer. If it is less than 3, then the answer is -1. Less than equal to 3, the answer is -1. Okay, now after finding, like, now you know that there is some answer possible. How many pipes will it require? How to find that? Okay, that can be easily done actually. If you see, okay, let's look at this 5. We opened this pipe, and this pipe. If you see, instead of opening first, third, and fourth pipe, the same can be done using opening first, second, and third pipe also. Let's try this. If you open the very first pipe and you have 5 seconds, you'll fill 1, 2, 3, 4, and 5. Now open the second pipe. Even though this is full, all the water will get flowed out to this 1, 2, 3, 4, 5. Now open the third pipe. Even though this is filled out, all the water will get flowed out to the next one. So 1, 2, 3, 4, and 5. So if you see, even by opening first, second, and third pipe, we were able to fill all the locks. Okay, so there is no need of skipping any pipe. Just open the pipes in this like order only, and whatever like through minimum pipes are required, they will be able to fill all the locks. Now, if you see, what is the sum? What is the sum of all these locks? Sum of all these locks is actually, we have 4 liters here, 1 liter here, 5 here, again 4 here, and 1 here. So this total sum is 50. And you have 5 locks. Okay, and you have 5 locks. But since, let's say for t seconds, okay, if you have to find an answer for t seconds, if you divide this 15 by t, you will get the number of pipes you need. Okay, that's all you have to do. Okay, because if it is 15, and let's say t is 5. If t is 5, 15 by 5 is 3. That means by opening 3 pipes, you will be able to fill. If this t is, let's say 4, 15 by 4 is actually like 3.75. That means if you round it above, this becomes 4. That means by opening 4 pipes, you will be able to fill all the dams. That's it. That's all you have to do. First, apply binary search. Find out the threshold number of time you need to fill all the locks. Then, like if the query is greater than that seconds, just find like sum by t. That's it. I hope this is also clear to everyone. Again, like I think problem D was easy. Like then it should, like it was easier than it should be. Like than other standard Ds. Okay. Let me show you the code as well. Again, pretty straightforward code. Okay, so this is the code. Okay, so first what I'm actually doing is I'm scanning the complete array and finding the sum of the complete array. Then right here I'm applying binary search, and through binary search I'm able to find out the answer, which is the minimum number of required seconds you need to fill all the locks. After finding that answer, I now know that if the query, if x is less than answer, this answer is the minimum number of seconds I need to fill all the dams. If the given seconds in the query are less than this answer, then the answer is -1. Otherwise, my answer is like sum plus x minus 1 by 2. This is actually like, there is another way of writing this, which is this is actually like sum by x, sum by x plus if some percentage x is equals to 0. Okay, then add +1. If you have to do this condition, then you do this, because like this is nothing but rounding above, because if you remember 15 by 4 is 3.75, and for this we need the answer to be 4. One way could be, you could actually make these double, find this in like float only, that it is 3.75, and then you could find the steal of this, which is 4. Other way is, you can actually write this complete thing directly as sum plus x minus 1 by x. Okay, that's it. All right, so that is all for problem D. Is this clear to everyone? I don't see many people in the chat. Why is that? Even though there are 70 concurrent viewers, I don't see many people writing in the chat. Why is that? Is problem D clear to everyone now? This is the binary search if you want to look at it. Looking D is more simpler than C. Yeah, I even think like D was somewhat simpler than C. Like for C, you had to get the intuition that okay, this is how it is going to do. For D, I think it was very straightforward if you tried some examples. Okay, all right. Is problem D clear to everyone now? They just say yes, perfect. Okay. Should I end the stream now, or is there anyone who wants to ask any other problem? Otherwise, I can end the stream. Crystal clear. Perfect. Perfect. Do like the stream, guys. Also, subscribe to the channel. I am close to 5K subscribers. Let me check how many subscribers do I have. Happening. How should we do dynamic A to OJ ladders? I don't know that. I have never done dynamic programming from A to OJ. The way I did dynamic programming was I actually went to the problem set of Codeforces only. What I did was I went to the problem set in Codeforces. Okay, so this is the problem set. Then that everybody can. Okay. So what I did was this has changed a little bit. Filter problem, yeah, add tag. Okay. If you add a tag of dynamic programming here, DP, get all the problems which actually require dynamic programming. Then you can actually sort these on the number of submissions or on the rating. So I think I used to do on the number of submissions. I do it on the number of submissions. Okay, like from higher to lower. Okay, and then if you see, I solved all the problems of the first few pages. Okay, and through that, like I was able to get better at dynamic programming. The other way is you can also do like a lead code of dynamic programming. That is also really nice. You can do CACS. That is also nice. CACS of dynamic programming is also very nice. How do we go to dynamic programming? Where is it? You can do all these problems as well in CSS. I have done these and they're really nice. They're very basic problems, which gives you a grasp of the basic idea of dynamic programming. Okay, so these are also really nice. Okay, cool. Is there anything else? Okay, this is also done. Okay, cool. I think it's better to end the stream now. Do like the stream, guys. Also subscribe to the channel. Okay, I was looking at my subscribers. Not opening. I have 4954. Okay, 46 more to go. All right, cool. I am thinking of doing a live Q&A session. Is that something you all are interested in? If yes, I can actually schedule that for tomorrow or maybe day after tomorrow. E and F got very less submissions. Like says yes. Brute force and constructive. Okay. Okay. Anyways, I'll think about the like live Q&A session and let you know. Okay. If I think like do plan to do that, I'll put a community post. I've never done that, and then we can do. And yeah, that's it. Cool. Let's meet in the next contest. The next contest is on 25th, I think. Yeah, on 25th, we have a global round. That's really nice. So let's meet on 25th with a global round. And yeah, that's it. Thank you.